So hello guys, today tuturuan ko kayo relating the derivative with the rate of change. Minus 40 plus 3 describe Arwin's motion. To show the location of Arwin at specific points in time, we use the horizontal number line in figure 36. So there. At t equals 0, s equals to 3, Arwin starts at point A, 3 meters to the right of point 0. At t equals 1, s equals 0, Arwin is at point 0. At t equals 2, s equals to 1, negative 1, Arwin is at point B, 1 meter to the left of point 0. At t equals 3, s equals to 0, Arwin is at point 0 again. We are using this graph to show Arwin's point. Observe that between t equals to 0 and t equals to 2, Arwin moves from s equals to 3 to s equals to negative 1, point A to point B. Thus, for an interval of 2 seconds, change directed distance from 0 is 4 meters, and the average velocity can be computed as v equals to s over y, or if you substitute it, it's equals to negative 1 minus 3 over 2 minus 0 equals negative 4 over 2, and you just have to simplify it, and equals to negative 2 per second. Arwin moves to the left from point A to point B. Note in illustration 1 that the average velocity is not constant. For example, between t equals to 0 and t equals to 1, s equals to 3 to s equals to 0, thus the average velocity in this period is v equals to 0 minus 3 over 1 minus 0 is equals to negative 3 minus over 1. And is equals to negative 3 per second. Similarly, between t equals to 1 and t equals to 3, s equals to 0 to s equals to 0, and it will, if you substitute it, will become 0 minus 0 over 3 minus 0 equals to 0 over 2, and equals to 0. Moreover, the average velocity does not describe the motion for Arwin at any specific instant. If one is driving an actual car, he or she will be interested to know his or her actual speed at a particular instant so that he or she will know how to control the car better. This is what is recorded in the car's speedometer, and is referred to as instantaneous velocity. How do we measure this? Consider the average velocity of moving object between t equals to t and t equals to t1. The corresponding displacement s equals to s0 and s equals to s1, given by v, velocity equals to s over y equals to s1 minus s0 over t1 minus t0. In order to get the velocity at a particular instant, such as t equals to t0, also called as the instantaneous velocity at t0, we simply take the limit of the average velocity as t is to approaches to t0. Thus, we have this formula: velocity t equals 0 equals the limit of t1 to t0, s1 minus s0 over to t1 minus t0 equals the limit of t1 to t0, f of t minus f of t to 0 over t1 minus t0. This limit exists. Notice that this is also how we have defined the derivative of the function f with respect to time, evaluated at t to 0. Therefore, velocity of t0 is equal to f prime t0. And in general, velocity of t is equal to f prime equals to ds over dt. So thank you guys for listening. I hope you understand